Welcome back, everybody. This is our second class in NEET previous year questions for chapter Oscillation of class 11th. Before this, we have made one video in this chapter series, and that video can be found on our YouTube channel. Again, name of channel is Point Basics, and there is a dedicated playlist for such type of videos. So you can go to our channel's playlist section, and there you can find that playlist. We have also started similar series for JEE mains previous year, so you can also check those videos out. And if you found these videos useful, helpful somehow, then do like these videos, share these videos as much as possible, and subscribe to our channel. It helps a lot when you share and subscribe. Also, if you want to support us financially, then you can scan any of these QR codes available on your screen and donate us with whatever amount you want. With your contribution, we will be able to keep on making such videos and keep on bringing you such content. So with this, let's start today's video. In previous video, we have completed up to question number 15, and today we will start further. So this was the last question number 15, which we completed, and now with question number 16. So here it is. Phase difference between displacement and acceleration of a particle in simple harmonic motion. So for simple harmonic motion, we know that acceleration is equal to negative omega square into displacement. Or we can write this equation as A is equal to minus omega square into x, where x is displacement and A is acceleration. So direction of acceleration is opposite to direction of displacement. So if they are means we can say they are anti-parallel. And if they are anti-parallel, then they have a phase difference of pi radian or 180 degree. Hence, option will be, the right answer is option D. Moving to next question. Average velocity of a particle executing SHM in one complete vibration. So here we are taking velocity, average velocity for one complete vibration, and we already know that for one complete vibration, suppose this is the mean position, so particle will go up in t by 4 time, then come back to original position in t by 2 time, then do negative maxima, and then again to original position. So here if we count distance, then distance is equal to, this is a, again a and again a, so distance is 4 times the amplitude for one complete vibration, but displacement is 0. Why 0? Because the particle after completing one vibration has returned to its original position, so that's why displacement is 0. And we know that velocity is equal to displacement by time. So displacement is 0, time is equal to 1 time period, so velocity will be 0, or average velocity is 0. Or what we can do, we can derive it using integrals. If you want a more you can say more precise method of calculating, more proper numerical method of calculating it, then we know that suppose displacement is given by a sine omega t. We know that displacement, we are using capital A. If displacement is given by a sine omega t, then velocity will be given by dx by dt will be equal to A omega cos omega t. Now we have to find average velocity. So average of any value which is dependent on time can be written as, so v average will be v dt divided by integral dt, and limits will be the time period which we are using. So here we are averaging over complete time period or 0 to t. So limits 0 to t, value of v is a cos omega t. So a omega cos omega t divided by dt, limits 0 to t. Now we know integral of cos a and omega here are constant, and integral of cos is sine. So it will be sine omega t by omega, and limits will be t to 0 to t, and integral of dt is again t, and limits is t to 0. And we forgot here minus sign, I think. Yes, minus sign we forgot. Integral of cos is minus sine omega t. So omega get cancelled, minus comes out, minus a as it is, limits sine omega capital T, and when we put 0, then sine 0 divided by t minus 0, that is t. Now we already know that omega is equal to 2 pi t, 2 pi by t. So from this omega t will be equal to 2 pi. Putting these value here, minus a sine 2 pi minus sine 0 divided by t. And if you know the sine graph looks like this. Here it is 90 degree, here it is 180, and here it is 360 or 2 pi. So sine 2 pi is 0, sine 0 is already 0, so 0 minus 0 and multiply something is also 0. So using this method we can also find out average velocity, and this method is more useful when you have to find average velocity over say half of the time period or t by 4 of the time period. Then limits will change here according to the question asked, that if we have to find average velocity for half time period, then we can say then average velocity will become, for t half, average velocity will become 0 to t by 2 v dt integral 0 to t by 2 dt, and then again we can solve the same process. So that's how you can find the right answer, and here it is 0, so we have already ticked it. Now moving to next question. A particle execute linear simple harmonic motion with an amplitude of 3 centimeter. So amplitude is given when particle is at 2 centimeter from mean position. So here we have displacement, magnitude of velocity is equal to that of acceleration, then time period in seconds. So we have to find out time period. So what we have amplitude, that is 3 centimeter, and displacement, that is 2 centimeter. And when particle is at 2 centimeter from mean position, the magnitude of the velocity is equal to acceleration. So magnitude and velocity and acceleration are equal. It means we have to find magnitude of both and we can equate them. So for simple harmonic motion, we know that velocity is given by omega into a square minus displacement square, and acceleration is given by negative omega square into displacement. So v at 2 at displacement 2 will be given by omega into amplitude is 3, so 3 square is 9, and 9 minus 4. And be in mind we are here using only centimeter scale, so if we have to convert, then we later convert into meter. So it will be omega root 5, and acceleration at 2 will be minus omega square into displacement, that is 2. So minus omega square, or we can say minus 2 omega square. And as per mention that magnitude are equal, so we have to ignore sign. Or magnitudes are equal means omega acceleration modulus is equal to velocity modulus, or omega root 5 is equal to 2 omega square. And from here omega get cancelled, and we have omega is equal to 2 by root 5. Now both of these were in centimeter, so centimeter gets cancelled with centimeter, so we don't have to convert it. And we have to find out time period. Now time period, omega is equal to 2 pi by t, and that is equal to further 2 by root 5. So 2's get cancelled from both sides, and what we get, t is equal to, I think we made a mistake here. It will be root 5 by 2, and so we have to correct it here also. So it will be 2 pi by t is equal to root 5 by 2, and from this t will become 4 pi by root 5, that is option C. Now moving to next question. A particle is executing simple harmonic motion. Its maximum acceleration is alpha and maximum velocity is beta. Then time period we have to find out. So maximum acceleration is alpha. Now acceleration for SHM is given by minus omega square x, and here x is displacement. So maximum value of displacement is equal to amplitude. So A max is equal to minus omega square into amplitude. So we denote amplitude by capital A, where A is amplitude, and this value is given equal to alpha. Now coming to velocity, again velocity is given by A, oh sorry, not A, omega into A square minus x square, where x is displacement, and velocity will be maximum when x is minimum or x is equal to 0. So it comes out to be V max comes out to be equal to omega times A when x is 0, and that is given equal to beta. So we have to find out its time period, and time period can be yes. So here we can also take we have taken here negative sign. Suppose if amplitude is on the other side, so this is the behavior of SHM. Here we take amplitude positive, here we take amplitude negative. So when amplitude is minus A, then it will be maximum. So here we have to add additional plus positive sign. Why? Because amplitude can take positive value and negative value, and we have to find out maximum. So maximum value should be positive. For that we will be taking acceleration along this negative side, and for this negative side value of x is equal to minus A. So minus A into minus omega square, we will get plus omega square A. Now we can divide both of these. So alpha by beta is equal to omega square A by omega A, cancelling both. What we get, omega is equal to alpha by beta, and omega we already know it is 2 pi by t is equal to alpha by beta, and from this time period is equal to 2 pi beta by alpha. So option D matches properly with our answer. Now moving to next question. Particle is executing SHM along a straight line. Its velocities at distance x1, x2 from the mean position are v1, v2 respectively. Time period is, so we have to find out time period. So for that, we will write equation for both and then solve them. So we know that basic formula for velocity is omega times a square minus x square. So we will write velocity for both of these values. So v1 is equal to omega a square minus x1 square, and similarly v2 is equal to omega a square minus x2 square. Now we will squaring both sides, we will get v1 square is equal to omega a square minus x1 square, and v2 square is equal to omega a square minus x2 square. Now you can see here we have some, in option A and option C we have addition of velocities, and B and C we have subtraction of velocities. So what we do, we will try both, we will add and we will subtract. So first we will add both of these. Case 1 where we will add both of these. So v1 square plus v2 square is equal to omega a square plus omega a square. So 2 omega a square minus omega x1 square minus omega x2 square. So here our amplitude is not getting, means we are getting this amplitude term and it is not getting cancelled. So what we try? We will try using subtraction. Case 2, v1 square minus v2 square. We will get omega a square minus omega a square. So this term will get cancelled, and what we will get? Omega x1 square, that is of negative, and negative again this negative term, so negative negative will be get positive, omega x2 square. So from this we can write v1 square minus v2 square is equal to omega times x2 square minus x1 square, and omega is equal to v1 square minus v2 square divided by x2 square minus x1 square. And what we can do now, here omega is 2 pi by t, so 2 pi by t is equal to v1 square minus v2 square divided by x2 square minus x1 square. Now t will be 2 pi, I think. What we have to find out? Time period. We have to find out time period. Okay, we made a silly mistake here, that when you squared, this will be also squared, so omega square, and here it is square square square, here it is also square, here it is square square, and then we will take under root of this. So now we have under root, so this is under root. So t will be 2 pi into x2 square minus x1 square divided by v1 square minus v2 square, and this can also be written as 2 pi If we adjust negative sign here, x1 square minus x2 square divided by v2 square minus v1 square. So let us compare what we get with the answers. So we have 2 pi, and both the terms are of negative, and here is x2 minus x1 by v1 minus v2 square. So x1 minus x2, x2 minus x1 v1 minus v2, x2 minus x1 v1 minus v2. So option B matches with our answer. So option B is the right answer. Moving to next question. The oscillation of a body on a smooth horizontal surface is represented by the equation x is given by a cos omega t. X is displacement, omega is frequency of oscillation. Which of the following graph represents the correct variation? So here we have given x is equal to a cos omega t. So for that, because we have to plot a graph, so what we do, we take t is equal to 0. We start with 0 value. Then what we will get, x0 is equal to a. When we put t0 here, then it will become cos 0, and cos 0 is equal to 1. So x0 will be equal to a. Now here we have acceleration versus time graph, not displacement versus diagram. So we have to also account for acceleration, and acceleration for this type of means SHM is given by minus omega square into displacement. Now here displacement is equal to a, so acceleration is also equal to, also acceleration will be equal to minus omega square a. So at t is equal to 0, acceleration will be negative maximum value. So if we compare with graphs, on first graph we have acceleration positive, so this is not answer. In B option, at time is equal to 0, acceleration is 0, again wrong, and here again at time is equal to 0, acceleration is 0. So only our option C, where at t is equal to 0, acceleration is negative, matches with our what we derived from the equation, what we found out. So option C will be the right answer. Now moving to next question. A particle of mass m oscillate along x-axis according to equation x is equal to a sine omega t. The nature of graph between momentum and displacement of this particle is equal. So we have to find out nature of momentum and displacement graph. So first we will find out value for momentum for this type of graph, and then we will do further. So let's start. We have given that x is equal to a sine omega t. So we have equation for displacement we already have, and we have to form equation for momentum, and for momentum we need velocity, then we can multiply it with mass and we will get momentum. So what we do, we will take a first order derivative of displacement, dx by dt will be a omega cos omega t, and here it is p. So momentum is equal to mass into velocity, and that will become mass a omega cos omega t. So we have now two equations. First is x is equal to a sine omega t, and second is p is equal to m a omega cos omega t. And we have to find out that if we plot these two, what we will get, circle, hyperbola, or ellipse. So what we have to do, we have to form a relation between both of these equations, and that can be done by, if we adjust like this, x by a is equal to sine omega t, and p by m a omega is equal to cos omega t. Now squaring both these side and adding, so x square by a square plus p square by m square a square omega square is equal to sine square omega t plus cos square omega t, that is equal to 1. Sine square theta plus cos square theta is equal to 1. So this is 1. And what we will get? From this we get x square by a square plus p square by ma omega square whole is equal to 1. So this is an equation of ellipse where we have x square a square plus p square by b square is equal to 1. When a and b are different, then it is an equation of ellipse. So option C is the right answer, and here length of the axis will be a and ma omega. These are the two that will be the length of axis. And if we know, this will be the ellipse. If it is O, it is A and B, then we know we might argue that OA is equal to A and OB is equal to MA omega, or vice versa, that OA is equal to MA omega and OB is equal to A. So this will be the length of axis, and this is equation of ellipse. Now going to next question. A simple pendulum performs simple harmonic motion with x-axis 0 with amplitude a, time period t, speed of the pendulum when x is equal to a by 2. So we have to find the speed, and speed we can find out easily using the equation that velocity is given by omega a square minus x square. So we just have to find the displacement, and then we can put the value of displacement and we will have the answer. Here amplitude is given by small a, so we denote it with small a. So here the main point is that we have to focus here that when x is equal to 0, the amplitude is a. When x is equal to 0, the amplitude is a. So displacement, so we just will put value of x is equal to a by 2. So displacement is given x is equal to a by 2. So velocity will become omega a square minus x is equal to a by 2, yani ki a by square, a square by 4, and here we will have omega 3a square by 4. And if you see these options, we don't have here omega, we have here pi and t. So we have to put value of omega. Omega is equal to 2 pi by t. So 2 pi by t into root 3 a by 2. So 2 will get cancelled, and here we have pi a root 3 by t. So here is option D is the right answer. Next question. So which of the following equation of motion represents simple harmonic motion? So here we have given acceleration in all of 4 options, and we know for SHM acceleration is proportional to negative of displacement. Here we have square terms, so this is not right answer. Here acceleration is equal to positive of displacement, so proportional to positive of displacement, so not again wrong. Here we have acceleration is proportional to negative times axis displacement. Here a is given constant, so you can easily ignore a constant. So this satisfies the equation that acceleration is proportional to negative of displacement. So option B will be the right answer. Next question. Two simple harmonic motions of angular velocities and of angular frequencies 100 and 1000 radian per second have same displacement amplitude, ratio of their maximum acceleration. So we have to find out ratio of their maximum acceleration, and their amplitudes are equal. So a1 is equal to a2 is equal to a, and we know that a max is given by omega square into A. So A1 max by A2 max will be omega 1 square. Omega 1 is 100. So 100 into 100 into amplitude A. Both of these have same amplitude. For second, omega is 1000 into 1000 divided by A. So multiply A. And these two get cancelled and these two zeros get cancelled. So ratio what we will get 1 by 100 or 1 ratio 10 raised to power 2. That is option B. Moving to next question. So here a point performs SHM of period t and equation of motion is given by x is equal to a sine omega t plus pi by 6, where pi by 6 is the phase difference. After the elapse of what fraction of time period the velocity of point will be equal to half of maximum velocity. So first we will find out that when velocity is half of maximum velocity, and then we will find out the corresponding time period. So we know that velocity is given by omega a square minus x square, and v max it will be equal to when x is equal to 0. So omega into a is the value of v max, and as per given velocity is equal to half of v max. So we can say that suppose velocity is v dash and it is equal to half of v max, that is omega a. So v dash will again be written by using this formula. So v dash will be omega a square minus x dash square. Here we using this we will find out the value of x dash. So half omega a, cancelling omega from both side and squaring both side, we will get a square minus x dash square is equal to a square by 4, and from here a square minus a square by 4 is equal to x dash square, and x dash is equal to, sorry, not 1, x dash is equal to root 3a by 2. So we will get we got the value of displacement, that at this displacement from the mean position velocity will be half of the maximum value. Now using this equation we know that x is equal to a sine omega t plus pi by 6. If we put value of x dash here, because x dash will also satisfy this equation, so x dash will be root 3. Amplitude is represented by small a, so we will be representing it small a by 2 is equal to a sine omega t plus pi by 6. A get cancelled, and we will find out that when sine is root 3 by 2, that is 60 degree, and we can say it is pi by 3 radian. So pi by 3 is equal to omega t plus pi by 6. From this omega t is equal to pi by 3 minus pi by 6, that is pi by 6, and from this omega is 2 pi by t into small t is equal to pi by 6. So pi get cancelled, and but we get that small t is equal to capital T by 12, and here is option D will be the right answer. Moving to next question. The phase difference between instantaneous velocity and acceleration of a particle executing SHM. So we have to find out phase difference between velocity and acceleration. So we know we will take basic equation that x is equal to a sine omega t. From here we know velocity will be a omega cos omega t. Velocity will be equal to dx by dt, and acceleration, that is represented by capital A because we have already used small a, is equal to dv by dt, will be equal to negative a omega square sine omega t. Now, to compare their phases, because we have to find phase difference between velocity and acceleration, we have to convert both of these into a single form. Means we have velocity in the form of cos and acceleration in the form of sine. So either we have to convert this cos into some sine form or this sine into some cos form. So here we will be converting acceleration into cosine form. So we can write accelerations like this: a omega square into minus 1 sine omega t. And now we will convert this sine omega t in form of cos. And we already know that sine and cos are interconvertible with each other using 90 plus theta and 90 minus theta. So we can use here cos 90 plus theta and cos 90 minus theta. These both will be sine, but there will be slight difference that this will go into second quadrant and this will go into first quadrant, and in second quadrant cos is negative, so this conversion will result in minus sine theta, and in first quadrant cos is positive, so this conversion will result in positive sine theta. And here we have negative sign, and in this equation we don't have any negative sign, so we have to absorb this negative sign. So to absorb this negative sign we will use this type of conversion. So acceleration can be written as a omega square cos 90 plus omega t. Now both have in the same form, and from this we can say that acceleration is ahead pi by 2 radian of omega t, and velocity have only omega t as in the form of angle, and in acceleration we have extra pi by 2. So we can say acceleration is ahead of velocity by pi by 2 radian, or the phase difference is equal to pi by 2, so that is 0.5 pi. So option D will be the right answer. Moving to next question. A particle executing SHM of amplitude 5 centimeter has maximum speed, the frequency of oscillation. So maximum speed or V max is given by A into omega, where A is amplitude, and that is given by 31.4. So A omega is equal to 31.4 in centimeter second, and we have all amplitude also in centimeter, so omega will be 31.4 divided by 5, and we have to find out frequency, and omega is equal to 2 pi by t and frequency is equal to 1 by t, so this will be written as 2 pi into frequency. From this, frequency is equal to 31.4 divided by 5 into 2 into pi, or 10 pi. So 10 into 3.14, that is equal to 31.4. So frequency is 1 hertz. Option D matches with our answer. Moving to next question. Which one of the following statement is true for the speed v and acceleration of a particle executing simple harmonic motion? So when v is maximum, a is maximum, so this statement is wrong, because velocity is maximum when x is equal to 0, but at x is equal to 0 acceleration is 0. Velocity is maximum but acceleration is 0. Value of a is 0 whatever may be the value of v, so this is also wrong. When v is 0, a is 0, this is also wrong. The option D, when v is maximum acceleration is 0, that is the right answer. So option D will be the right answer, and that can be find out using basic formula for velocity, that is omega a square minus x square, and for acceleration we have minus omega square into x. So acceleration will be 0 at x is equal to 0, and when x is equal to 0 velocity is maximum. So option D is the right answer. Next question. A particle starts simple harmonic motion from the mean position. Its amplitude is a and time period is t. What is displacement when speed is half of the maximum speed? So again it is given that speed is half of the maximum speed, and we have already done such a question where we have find out the time period. Let me show that question. Here it is, I think. Yes. So here it is, this question. When we found out the displacement, here it is a statement that point performing SHM equation is given by this, and after what elapse of time period velocity is half of the maximum. So here only equation changes, but we will not be using this equation to find the condition when velocity is half of the maximum. Maximum velocity is given by this, maximum velocity is this. We consider some point where velocity is half of maximum velocity, and when we solve we find the value of displacement is equal to root 3 times amplitude divided by 2, and that is the answer. Here root 3 times root 3 by 2 times the amplitude, so option B is the right answer. So with this we finish this video here, and hopefully whatever we have covered is helpful and useful to you. Again, if you find this videos useful, then you can like this video, subscribe to our channel, share as much as possible. If you have any doubts, then you can put them in comment section. I will try to answer them and all. And if possible, do make some donations by scanning any of these QR codes. With your donations, we will be able to keep on continue such videos. So with this, again, thanks for watching, and we will meet in next video.